Welcome to the solution of LeetCode problem 1382, named balance a binary search tree. Here in this problem, we are given a binary search tree and we have to return a balanced binary search tree with the same node values. And if there is more than one answer, we can return any of them. But we have to ensure that the resultant tree is height balanced. Here, the height balance is the depth of the two subtrees of every node never differs more than one. So we have to ensure this condition. Here, if we consider the first example, the tree is 1, 2, 3, 4. It is the one binary search tree. And here, we can reform it in these two ways, either 1, 2, 3, 4 in this way or 2, 1, 3, 4 in this way. We can return any of them. Both of them are correct. I hope you understood the problem statement. Now let's move on to the algorithm. In this problem, to understand the algorithm, we have taken this example here. The root is 6, which has two children, 2 and 8. 2 also has two children, 0 and 4. 4 also has two children, 3 and 5. And 8 also has two children, 7 and 9. So we have to reform it, or we have to make another binary search tree with these nodes. So how can we do it? Here, the basic intuition is if we perform the in-order traversal in a binary search tree, the resultant array will be always in the sorted order. So here, if we perform the in-order traversal, the first node we will visit is 0. Then we will go to 2. Then we will go to 3, 4, 5, which is 3, 4, 5. Then we will go to 6, which is the root. Then we will go to 7, 8, 9, which is 7, 8, 9. Now, I have to make a binary search tree with these nodes. So what is the optimal solution? The optimal solution is here, if we consider a binary search technique, that means it is our left node, it is our right node, and this is our middle node. And if we make a root with 5, in this case, we can ensure that the resultant tree will be height balanced, because for this root 5, we have this left portion, we have this right portion. So here, this left portion will form the left subtree, and this right portion will form the right subtree. And here, the left portion value will be smaller than the root, and the right portion value will be greater than the root. Now, let's understand how the binary search works here. So the root is 5. It have left children, which is, it have left portion, which is 4. Now, for this left portion, the middle is 2. So we will make a connection between 5 and 2. So here for these two, it have two portion, one is left, another is right. For the left portion, it has 0. And for the right portion, it has 3 and 4. So for the portion 3 and 4, the middle element is 3. So we will make a connection 2 with 3. And 3 does not have any of the left portion, but it has the right portion. So we have to add 4 into the right child. Similarly, we can make this operation into the right subtree. So here, the mid value is 7. So we have to make connection with 5 and 7. Now it has a left child, which is 6. And it has a right portion, 8 and 9. So for 8 and 9 portion, the mid value is 8. So we make a connection between 7 and 8. And here, 8 does not have any of the left portion, but it has a right portion, 9. So we will make a connection 9 here. So we can say that this resultant tree is the height balanced binary search tree, which is the reformed version of this input tree. And this is how basically we're going to solve this problem by using the binary search. I hope you understood the algorithm. Now let's move on to the code. In this question, we are given a function named balanced binary search tree. Now we are calling an in-order function into the given tree root. Inside the in-order function, we are storing all of the root value into the corresponding vector into the in-order fashion. So here in the in-order function, if the root is null, we have to simply return. Otherwise, we have to recursively call the in-order function on the root left, and we have to recursively call the in-order function in the root right. But before this, we have to insert the root into the vector VC. Now, by using this vector VC, which is the sorted order, we are calling this tree generation function. Now in the make tree function, which takes the vector VC and left and right pointer as a parameter. Now if the left pointer is less than or equal to right, we are calculating the mid, which is left plus right divided by 2. Now VC of mid, its left subtree will be recursively called the make tree function with the vector VC L and M minus 1. And similarly, the mid values right subtree will be the make tree vector of VC M plus 1 and R. And we have to return the mid value. Now, if the left is greater than right, we have to simply return null. Finally, we have to return the generated balanced binary search tree. I hope you understood the code. Thank you everyone for watching the video. We will get back soon with another LeetCode solution.